Great. Hi, everybody. My name is Ken Fogel, one of the organizers of this annual J Champions Conference. Thank you for coming and attending. Today, or right now, we're going to hear from Kay Horstman, who's going to be talking about Java for small coding tasks. Take it away, Kay.
Yeah, hi, thanks very much, Ken. And so Ken is not just one of the organizers, he is really the principal brain behind this fantastic event. So it's my honor to be a part of this. I'll be talking about how to use Java for small programs. So think shell scripts. You may have seen this cartoon where one starts out writing something as a shell script, and then it gets too big. And now in this cartoon, they use like Node or Ruby or Python. We will be using Java. So the joke goes that then once you find true enlightenment, which we will not find, then you go back to shell scripts. We will be plainly at the point, hopefully, above the median intelligence scale here, where we will be writing stuff in Java. A couple of words about myself. I'm the author of the core Java book, 13 editions since 1996, almost starting to work on the 14th edition, and a bunch of other books. So again, why small Java? You started with some scripts, you want to automate something, you may want to explore a new API. And when you do that, then you certainly not want to start a project with Maven or Gradle because that's actual work. And anyway, why use Java? Well, first of all, for us Java people, Java is familiar. It flows out of our fingers. And Java is stable. If you write something in some other languages, it might not work after a few years. I used to do a whole bunch of scripting in Scala, which is a delightful language. Unfortunately, it is a different delightful language every few years. And so my old scripts then take some amount of trouble to keep working. Java is portable. It's in fact more portable than shell. If you have a shell script and you want to run it on Linux or on Mac OS or on Windows, you're going to be having subtle issues. Whereas if you use a Java program, chances are it'll run without change on all three platforms. Now, the big thing for me is that Java is compile time typed. That means when I make a mistake, which I do distressingly often, then the compiler tells me about it rather than me having to find out when the program runs. Particularly when you do kind of exploratory programming, you don't yet know what you're doing. You can create a great deal of damage when your shell script runs awry. So it's a good help that the Java compiler keeps me from doing the most foolish things. There's a vast ecosystem of libraries in Java. Of course, in Python, there's also such a large ecosystem, but if you just rely on shell, then not so much. So why not shell? We talked about it. It's fragile. You start a shell script. It seems so easy. You make a few changes, you come back to it after a week, you don't understand half of the things you did, then the world changes, it needs to get bigger, it gets bigger and bigger eventually, and actually pretty soon it becomes maintainable. So why not Python? There's nothing wrong with Python, it's a fine language, but it's not compile time typed. And also if you look at the tools that you have available in Java, I put it to you that the Java tools are much better than what you have in Python. Why not Scala? I mean, I love Scala. It's super expressive, but it is more difficult to master. And like I say, it's not super stable. So why am I giving this presentation now? Because there are a number of changes in the world of Java that make it easier to do this kind of programming in the small. Oh, I should say, by the way, that if you want to ask any questions or if you have comments, feel free to do those in real time. I see a bunch of hi there, so hi there to everyone. But I can just interrupt and get to your questions right away rather than having to wait till the end. All right, so there is a JEP for launching a single file source code program, and then another JEP for making that with multiple files without having to compile them. And so all you do is you say Java, and then the name of your Java file. So normally you do Java C, and then your Java file, and then Java and the name of the main class. Here, you simply say Java, and it'll compile the program in the background. Now, you might say, big deal. You just have one command instead of two. But the big deal is that when you do that, you don't clutter up your world with class files. So if you have a simple script, then it feels like supernatural to do it as a Java program. Now, in fact, you can automate that a little bit. If you make the first line of your file a Unix shebang, then you can actually launch the file by just launching the file without even having to say Java, by just in the normal Unix way. There's only one fly in this ointment. If you do this, then you must rename the file. So it can't end in .java because it's not legal Java code, and so Java is very fussy about that. And so that's a little bit unpleasant when you edit the script, because your editor is then going to get confused, thinks it's a shell script, and it's not going to use Java syntax editing and so on. There is a remedy to that, and that is you can make the first line, this little beauty here. You use a triple slash, and then the magic here. And when you do that, then it's both a shell script and a Java file. Now, what makes it a shell script? Well, it starts with, so you don't actually have to have a shebang. You can, there's arcane reasons why this works. And notice the exit here. That means after the shell reads this first line, it's going to feed the file to Java, and then it's going to exit, and it's not going to see the rest. Java, on the other hand, sees the two slashes here, and then it thinks it's a comment, and it'll only read the rest. That's a nifty little trick here. So let me just show you one of these. So I have this script here. I'm going to make it a little bigger. That does, you don't want to know what it does. What it does is it's a part of my backup pipeline, and it picks 10 random files in the file system, and so that they can be restored. That's all it does. And so I can now run it by, find a terminal, by saying bin backup filter.java, and then it goes off and runs it. And so that's, it's super convenient. Now I can edit it as a Java file, and I can run it as a shell script. It takes a bit because it has to go through the entire file tree. It'll come back in a couple of minutes with a list of 10 files or so. All right, while it does that, let's move on. The next thing that makes our life easier as JavaScripters is another JEP 477, that is meant to make it easier for developers to get started with Java programming. But we are going to hijack this JEP and saying it also makes it easier for us to write small programs. So there's a few ingredients for this. First one is that you no longer have to say public static void main. You can just say void main. Well, that's nice. Notice also you don't need the string parameters if you don't have args. And you actually don't even, if you have a single class, you don't even need the class. You can submit the class, and everything that is inside here, that's what goes into your file. So you have instance variables, you have methods, and then you have the main method somewhere declared in the simplest possible form as void main. And this makes an implicit class. The name of the class is the name of the file that contains all of this stuff. And there's another convenience that you can, well, first of all, there's an IO class that gives you methods print, and read on, so you don't have to say system out print on, you say io.println, which saves a few letters. And also that IO thing is already imported. In fact, everything in Java base is imported. So you don't have to start out with a ton of import statements. And it saves a few lines, but I first said, big deal. Maybe for someone who learns Java, this is useful, but for a programmer, we can live with public static void main and so on. But actually, I've come to really like it. It gives you there's more of a fluid Pythonic feeling, and I'm very much for it. So let me just show you one of these again. So when you look at this file, you see there is no imports, even though I'm using ArrayList, for example. There's no class, because this is all in one class. And you see there's a fair amount of code here, but these are all just functions, really. And they're not particularly difficult. And finally here, I have void main. And that's the structure of it. It kind of looks like Python with braces. That's certainly the feel that you get, except you get autocomplete in your IDE. You can, if you need to, you can throw it into the debugger, and so on. Oh, and let me show you actually. So this thing came out of a shell script. And so here's right now the shell script just calls into the Java file. But if you look at this shell script here, this was at the verge where it became kind of hard to maintain. What this shell script does is that wherever I am in the world, with whatever mics I have plugged in, whatever speakers I have plugged in, it picks the best one. So it's useful for if you need to give an impromptu presentation or a Zoom call or whatever. And so having rewritten it in Java, I get just a lot more structure out of this. I could have, with a bunch of effort, written these functions here in shell, but I would have never done it. And when I need to make changes, which is what prompted this, this is code that I can read where I know how to make changes to. All right. So records are actually surprisingly useful when you do this kind of programming in the small. It often happens that you have some data that are related, and by tossing them into a record, it makes your code easy to read. So yeah, actually, if we go here, this started out with a record because for whatever reason, these audio sources and sinks have attributes and properties and ports and whatever. I just put them for each of the many sinks and sources that the audio system has. I parse this little record from some file, and then I can work with the record instead of having to deal with individual variables. Now, Python programmers often use ad hoc lists or dicts for these kind of things, but it's nice that in Java you just give them a name, and then that way when you have a source or a sink or something, you can do something with it. So in Java, the cost of giving a name is just super low. Here's the name, and here you have the things that are inside the record. You get free toString equals hash code, as you know, and that's also in small programs. It's very useful. You instantly can put things into sets, for example, because the hash code's already there. And for any kind of debugging, having the toString is useful. Now, the other key thing of having records is that as your code gets to be a little bit more intricate, you sometimes have like little helper functions, and they often fit in very neatly as methods of these little records. So this is something that I did from a advent of code competition thing where there were bricks and I needed to figure out whether two bricks overlap. Well, that's a method in the brick record that says, does my brick here overlap with another one? Also, even though we already get the benefit of having classes imported, if we have an implicit main class, you can also consider simplifying your code with static imports. For some reason, many people are kind of nervous about static imports because they figure if you dump in too much import, then there's a fear of conflicts. But if your program is relatively short, that fear is probably overblown. And it really does make your code easier to read. So here I'm importing statically everything in system and math. And instead of doing system.error, I can just say error. Instead of saying math.square, I can just say square root and pi. And that's nice. Also, enums are nice. In Python, people just use ad hoc numbers, and we have enums. I use var for variable names all the time. So here you see a bunch of vars. Here you see a pattern because my fingers were faster than my brain. But more often than not, I find myself using vars. And of course, sometimes you want a diamond because if you have you can't use var for global variables. But then when you initialize it, then you make use of the diamond. Keep your code short. Java has all these features to make the code short and readable. In a long program, you might not want to use var so much because you ask yourself, what the heck did it mean or something. But in a short program, it's fine. Now, you might worry, well, if I come back to this 6 months later, do I then know what the type is? But you do have an IDE at your disposal, which will tell you what the type is, unlike, maybe in Python where there's no good way of finding it out. And so types are great for documentation. Sometimes when you have a bunch of data that you want to keep together with the code, you throw it in a text block and then you read through the text block. That's easier than having another file, because when you do scripts, you don't want to have too many side files that you need to worry about when you move that script from one place to the other. So text blocks are a win there. Also, a minor tip here. What I often found is I would start out with making something as an array, because I figure array, hey, pleasant syntax, brackets, compact. But then more often than not, that array then needed to be refactored into a list, because out of a sudden it was no longer fixed size. And so what I now do is I always start out with lists. And so it's a tiny little bit longer at the start, but more often than not, it pays off as the inevitable refactoring comes. And by the way, you think that you're writing this script that's only there for a day or two. And I'm amazed by how many of these little scripts that I've been writing over the last couple of years, how many of them I do come back a few months later when I have to do a similar task again. And so having a little bit of refactoring in mind is a good idea. You would not use the Java platform module system for anything like this. That's a very big iron tool that's on the other side of the spectrum. When you want to do some real work, then it's really helpful to have a language that has a great API. And Java really has a fantastic API. If you look at the API for strings, regex, collections, datetime, these are really very good. I've done similar tasks with Python or with JavaScript, and quite frankly, I prefer the Java APIs. The new I/O feature, everything that does the NIO file, NIO path, that is really, really very nice. I'm gonna stop this because I see there's a couple of remarks here. So someone is, if I have these scripts in a GitHub repo, and so I absolutely do not, because I don't think you would benefit very much from them, because they are all very targeted. So as an example, I had to do a script a few days ago to rescue some email that got lost because something crashed, and I had to get the SQLite dump of the Thunderbird database. I mean, that's super specialized. Or I have to like sling some JSON for something. So the entire idea of these is that of the scripting is you have some task that's important to you right then and there. You want to automate it, but it's not something that's necessarily worth sharing. And you don't mind being quick and dirty about it. So if I look at this code, this is code that I would not want to put in a GitHub repo, because then I'd have to start documenting it and making it bulletproof. And that's exactly not where I'm at. The talk, on the other hand, I should say that you can all follow. Let me see if I can be smart enough to put this in the chat. No, I'm going to ask Ken later to do it. If you can see it here, it's at horseman.com presentations 2025 J Champions. I'll figure out later a way to get it to you. All right, so back to the new I/O. So reading files. If you still have bad memories of Java using like a loop with buffered reader, those days are long gone. You can now read a file in a single instruction. You can read the file as a string, as a list of lines, as a stream of lines, whatever you want. Writing files, all of that stuff is super easy with just a couple of calls. So I'll give you a link here to see some of those. Streams can be nice when used with restraint. As always with streams, you can go overboard. But if you need to do simple computations like computing a sum or a max or min, or you need to like toss something into a map, there's some stream idioms that are super nice. You can deal with processes. The library is somewhat pedestrian, but it works. You can use HTTP clients. You could also write an HTTP server since Java 22 or so. And so those are just fine. There's nothing wrong with it. If you need to do XML, which I have to do, I would say serviceable describes the level of quality of that. There's a few things that are missing in action, and most importantly and painfully for me, that's JSON. It is a shame that right now there is not a JSON library that's part of the standard library. Of course, you can use Jackson, but then we'll talk about the challenge of including Jackson in a minute. The other thing that really ought to be a part of the Java API is command line argument parsing. There are good libraries for that, but hey, why isn't that part of Java itself? The other thing that is really missing in action is, yeah, of course, I can just use Jackson, or I can use Pico CLI, but how am I going to get this to a single file project? This whole thing that you've seen compiles a single file or maybe a small number of related files. And there is no support for Maven libraries. And there's a good reason for that, of course, and that is that Java knows nothing about Maven. It's never occurred to Oracle that such a thing as Maven exists. It's not any part of anything that Java specifies. It happens to be on there, and none of the Java tools support it. So there's two ways to get around that annoying restriction. The first one is sometimes I just actually use simpler libraries. Jackson is pretty complex and it pulls in a bunch of stuff. But some friendly soul has written a one-file JSON library with a simple API that's good enough for simple and short purposes. Same for command line parsing. This JARCS library has that. So just as a quick demo here, someone asked if I'm going to do live coding, and maybe I should do that some other time. But today, unfortunately, I'll show you a bunch of stuff, but I'm not actually going to do many modifications to it. So here I have something that it makes a JSON file. That's all you want to know for doing something with a publishing system. And so you have a bunch of Java code, and where the details are tedious, and the only thing that I want you to see is here it makes a JSON object, and it has like this really trivial API where you make an object by giving name, value, name, value, name, value. It's of course not very strongly typed because these things could be nested JSON objects or they could be strings. So it's live, but it's super simple. And the point that I want to make is that this JSON thing is in a single file. So it's in a single file with admittedly 2097 lines, but I just toss it in there and then my script works. So that's one way of dealing with the fact that there are a few gaping holes in the Java API. Okay, I'll show you another one later. Okay, another thing that you worry about, and that where Java is not so super suitable, is checked exceptions. Yeah, thanks for putting those links there. Now, checked exceptions can be a pain in simple scripts because in a simple script, normally you're okay with just terminating with a stack trace. I mean, as long as it gets stops and not like a shell script just keeps on running, you're fine. And what I do is I do what I've learned from my students. I just put throws exception to each method that might throw a checked exception. It's a little ugly, but that's what I do, including main, and then the script just terminates. Now, these implicit classes were there to ease the on-ramp into Java. And I would love it if Oracle could make it so that as long as you're staying within that on-ramp, that checked exceptions are essentially turn off, meaning that all methods do this, but I'm not holding my breath. Now, the other pain is, of course, in Lambda expressions. Now, you often do Lambda expressions because it's common to produce to do something with directories. When you have a directory, the easiest way of reading it is to get a stream of the files in it, and then you want to map it, and then you want to do something. And if the thing that you want to do, if that is an I/O operation, then it throws a exception, and then you have to uglify it by trying and catching it right inside that Lambda, and now your code looks really ugly. There is a way around. There's several sneaky throw libraries that you should, of course, never use in real production code. But I think if you have a simple script, it is a viable way around this issue. So check that out. So when it comes to how now the nuts and bolts on how to do this, I wouldn't use like a bare bones editor like VI or Notepad++ or something, because you do want all the goodness that you normally get from an IDE. You want code completion. When there's a coding error, a syntax error, you want to see it. And so one good choice is to use what I call a middleweight code editor, that such as VS Code or Emacs or Vim, where you use what's called an LSP, a language server protocol, I guess. And so for Java, there is such a thing. In VS Code, it's built in. With Emacs and Vim, you have to configure it, which is a bit of work, but it's perfectly doable. And the principal reason to do that is you don't have to worry about like any project hierarchy. Normally, when you do a project, you set it up in the Maven or Gradle ways, source main Java. Then that gives you already a complicated mess of files. Whereas now I just write them as Java files, and then I just edit them with one of these editors that has support. So I have VS Code running here, for example, and this is VS Code running right inside this bin directory where I have a ton of other utilities in there that have nothing to do with Java necessarily. They're just all there. And I can just open this file here, and I can then, if I want to, I can just run it from here. And then it runs this audio program, and it tells me what audio devices I currently have attached. I hope you can still hear me, so that it didn't mess up with the video here. All right. So, so we did this. And I just gave a couple of hints here what you might need to do to run with, if you do this, try this at home, if you run this with Java 23. Now, what about using a normal heavyweight IDE? For most of you, that'll probably be IntelliJ, or you might still be using Eclipse or NetBeans. They tend to be a bit hostile to simple file hierarchies. When you make a new project, IntelliJ will give you source main Java from the get-go. And so the key is, don't make a new project in the IDE. Instead, you put a starter file where you want it, and make it a Java file, put in just a trivial main, and then you tell your IDE to make the project from existing sources. The latest versions of IntelliJ and Eclipse do this just fine, and I think it's because they want to support the those JSRs with the on-ramp. And then they will, in fact, against their better judgment, make it so that your root directory can contain Java source files, and you don't need to use source main Java. If you have an older version of IntelliJ, you might have to do some nasty fiddling with the project structure, but it can be done. So I have IntelliJ here, and this is have a bunch of lost email things here, and no source main Java. That's something where I collect these emails, and I need to find them and massage them and put them in the right place. And so I have a couple of scripts that do these things because they came from two different sources. And the point that I want to make is this is right here in IntelliJ. I get auto-completion and everything, and I don't have any source main Java. I can debug, and that, of course, is also a key that once your script gets complicated enough, you have now all the power of the debugger. Someone says, what about JBang? Hang on, it'll come just in a minute. I'm not going to fiddle with the project structure here because if you just get the latest version of IntelliJ, it's no longer necessary. A couple of other things, and I will get to JBang just then, is you could try to compile with Growl because you think a Java program is kind of slow, particularly if it gets recompiled every time. Although I must say, I have not once in the last 2 years when I've started doing this at scale, been in a situation where the Java program, including compilation and running it, was too slow. But if you wanted to, you can make a native image. And so I actually have one application for that. I have a little tool that moves windows around on a screen so that I can do like a poor man's tiling window manager if I feel like it. And I wrote it in Java. And then I compiled it just to show that it can be done into a native executable. And it does start up mildly faster. So if I do it with the native executable, I get it here in 0.3 seconds. And if I do it with Java, then I'd get it in 0.8 seconds. And if that difference matters to you, then go ahead and use Grom. The disadvantage, of course, the executables aren't particularly small, so it produces a 15 meg executable. But hey, what's 15 meg? Some people say, well, why are you not using JShell? Isn't JShell meant for these kind of things, for scripts? Well, JShell is actually not that good for scripting. It's great for experiments. I must confess that 90% of my JShell experiments are fussing with regex. So, I might type in something like this that I copy from somewhere where it didn't work into JShell just to see, why the heck is this regex not working? And then I mess with the regex until it works. And then I copy and paste it back into my program. All that copying and pasting gets pretty awkward with longer code. There are some ways of making it simpler, but they're not really great. Some IDEs include JShell, but when they do, it's always, unfortunately, very poor. I'll get back to a better way of doing that in a minute. Now, one could write scripts in JShell, but Oracle actively says don't do that. JShell is meant for exploration and not for scripting. It's not so easy in JShell, if you want to explore something, to explore a third-party library, and that's kind of a shame because exploring is often something that you want to do with a third-party library. And so there was a fellow who wrote this hack, which I've been using sometimes, where you can use a third-party library, and I'll just show you, and so then you'll see what it's good for. So I'm going to start JShell. Let me find the terminal. With this little hack. And what it does behind the scene is it makes a trivial Gradle task so that it resolves this Maven coordinate that you see here. Takes a minute, of course. This, by the way, now is the class path that it has. And so this little thing here pulled in a whole bunch of stuff as it's wanted to do. Now I'm in JShell, and now I can actually run code with this particular library. It's a data frame library. And now it loaded from somewhere some data and put them into this data frame. And I can now continue to see what can I actually do with this. So I say, whatever this variable is, and it now tells me like all of the methods that are in there. And I can go my exploratory way. Okay, that's just a nice trick to know on how to deal with the wider world of Maven when JShell should be doing this, but they're not doing it. So, but really what you want to do is, so what I've shown you so far is how to do things without external tools, only with things that come with a JDK or, of course, with IntelliJ. And if you have the choice, you can save a lot of hassle by using this wonderful tool called JBang. So JBang lets you do the scripting for Java starting with Java 8. You don't have to wait till whenever that JSR for single files was in there. But the killer feature of JBang is that JBang deals with Maven dependency declarations the way that really Java should. All you have to do is you do //deps, you do your Maven coordinate, and somehow JBang puts it in the right place, includes it in the class path, and runs your script. You can also, in a similar way, add compile time and runtime options. And then it has a whole bunch of convenient features. This is not a presentation on JBang, but once you use it, you will find these really nice. You can make a fat jar, just like that. So there's no POM, no Maven, no inscrutable commands, no plugins. You simply make a fat jar. You want to make native image, here you make a native image. You can get templates for some things, like if you want to use Pico CLI, you use the CLI template, and it gives you a starter code for it. So nice. You can launch JShell with dependencies by first setting up some program with some of these deps, and then you say -def interactive, then it runs the code in here and drops you into JShell. Very nice. You can launch an editor where it sets up things with symlinks in the source main Java way, the way that an editor IDE might use it. You can use a debugger in the same way. So there's a lot more to know about JBang. And so if you are looking into the scripting, you really owe it to yourself to use JBang. But to get started with JBang is super trivial. All you do is you make this the first line of your file, and then you use //deps to include any Maven coordinates, and that's really all you need to know. All right. So far, what I've been talking about is how to do the kind of classic shell programming. You write shell scripts, you need to automate some task. I've talked a little bit about exploratory programming in JShell and how JShell is nice for exploring things like regular expressions or a simple library if you use that trick to somehow get the class path and communicate it to JShell. Or, of course, to use JBang and then do that exploration with JShell started from JBang. There's another kind of exploration that is very common in the world of Python with what's called Jupyter notebooks. So when I deal with data scientists, they always use Python. I've done this with business people. One time there was a dispute about royalties, and instead of sending a spreadsheet that's completely inscrutable, I gave them a Python notebook. So in a Python notebook, you don't write a program in the traditional sense. You instead fill in code cells, and you can also put in cells for comments and things in Markdown. And the beauty is that you get this visual output of any tables and graphs. You can put in sliders to move things around and to change inputs. It's all very, very nice and very visual. You can run them locally, or you can share them. And the sharing is really the key thing that you can, that's what I usually use. There's a service from Google called Google Colab that lets you do that. We'll see it in just a second. Now, those are, of course, with Python, but there is a project to make it simpler with Java. So if you look at this GitHub site, they made it so that you can take your regular Python environment and install what's called a Java kernel. Let's show this in action in just a minute. So you put in this magic here that does the Java kernel installation, and now you can write your notebooks in Java instead of Python. And again, better language and all of that. You can include Maven stuff by doing this %Maven magic, and then you can write your regular old Java code. So one can do this locally. Let me show that here. Sorry. Oh, no. Okay, now I need to put those so we can see them. So I'll load this chart class. That's the code that we've just seen. And when you run it, then you get this little chart here. And so if I were to change the data here, then I run it again. And then the chart changes. So you can see you can do these kind of simple experiments. You can get the data. You can visualize them. And the beauty is you can do it in Java. Now let's do the same thing in Colab. So we go to this site that this Java, this Jupyter Anyway people came up with. Here is the magic code that we run. It was not authored by Google, we know. It takes a minute to do this installation instruction. That's the drawback with it. The reason you want to use Colab is so that you can share things with others. But the downside is one does have to go through this installation phase here. Okay, while it's doing that, let me see if there are any questions. So now it has done this collection here, and now I need to switch to the Java kernel, which is, I believe, this one. I'm not totally sure. And now let's run this one here. Why is the runtime disconnected? Let me see if I picked the wrong kernel. Okay, I think the demo gods are not my friends today. What it will do once it all works, and it just takes a while for, unfortunately, it'll print. This is very much Java, and you can see that it's not Python because, of course, Python wouldn't have system out println. All right, so you can do this thing in with Jupyter Notebooks in Java, but it's not really as good as it is in Python. I've found at least 4 different Java kernels, and this is where we just got into this confusion. There's a thing called iJava that's been around for a long time, but it's not very well maintained. Then it got forked into JJava, which I believe is what Jupyter Anyway was trying to install. There's 2 others that have other seemingly appealing aspects, but why do you have to choose? And in the world of Python, everyone uses NumPy. So I found at least 3 different good-looking Java libraries that could potentially do something similar, and one would have to pick one. What about plotting? I mean, I found a bunch of charting libraries. And there's, in fact, a couple more that I didn't bother to put on here. But that's not a canonical one, and that's the disadvantage, because these libraries in Python, they're not actually very good, but there's only one of them, and so when you ask ChatGPT on how to do something, it'll give you an answer. Whereas in Java, you don't quite have that. But it's still early days for Java, so that could come. So there is also a very nice project that just started, and there will be a presentation about it in this conference in a few days, called J Taccuino, Taccuino's notebook in Italian, that lets you work with it. Let me just show it to you. It's easier to see it than to talk about it. And I've just rebuilt it from source because there hasn't been a version published for a few months. All right, here it comes. Let me resize this. So this is a Java FX application. And so if I open a file, like they have a little demo here, that when I run it, gives us like a little scatter plot. Or if I open this is the same code that you've seen before. Notice that the magic to add a library is a little bit different, but again, I can run it and it does this chart. Now, Here again, we see these little cells. I could add a new cell if I could figure out how to do this. That was the wrong way. Okay, well, and now I can put in more code in here. And the point of it is it does have some creature comforts. It has, for example, auto-completion, where it shows me the various methods. It's not as nice as it is in IntelliJ because you don't yet know what these methods do. But this project is still in its early days. So if you contact the creators of this with your many wishes, then it has a real good chance of growing into a really fantastic tool. So this thing does use a JShell in the background. You don't need to know that. For you, it really has the feel of kind of a higher quality notebook environment. So go check it out. You can also run Jupyter notebooks in IntelliJ, and where you do get good auto-completion and debugging. But as far as I know, only for Python and Kotlin. I have not been able to get it to work with Java, which is a shame. And one can also wonder, is there a world beyond notebooks? The notebooks, don't have great code completion. The error reporting is kind of crappy. It's weird that you can execute these cells out of order. There's a good reason for it. Sometimes you have an expensive computation and you don't want to repeat it. There's no debugger as far as I know. And when you save it, they're saved in the most obscure JSON format and you can't really diff it. You would like to be able to diff the source code so you can see what changes you made in your project, and you really can't. So there are a couple of experimental projects that I won't have the time to demo today. I'm just giving you a link to one that tries to use JShell as the base and then render to HTML so that you can see nice graphs. And so the question that I kind of want to plant in your mind is there some kind of a happier medium between something that's more like code that you can run in an IDE, but that also gives you the same benefits of a notebook, that you have this very exploratory feel, that you can see the graphical stuff like right in line. And I feel there's room for that. And so in Python, everyone uses notebooks, and probably that innovation is not going to come from Python, but it could come in Java. So support projects such as JTuck and see what they could deliver for us. Just a very brief notice here on Java in the browser, and then I'll go have another pass through your comments here. Remember applets? It used to be that you could write small and simple Java programs in your browser in a safe and sandbox Java runtime, except it was not so safe, and so eventually the sandbox died. And now no browser runs Java anymore, but they can all run WASM. Unfortunately, WASM today is not really a good target for Java. There's no GC yet, although it's coming. There's no threading. But there are some projects that actually try this. So if you check out TVM and ChipJ, you can see that there are the beginnings of being able to do Java in the browser. And it's not totally ridiculous. Let me see if I can find this thing that I preloaded, because it takes forever to load. Otherwise, we're not going to do it. Yeah, here it is. So here, these people took their like 1999 style Java IDE and put it into a browser. So this thing runs in a browser, and you can see it actually has simulated Mac, ancient Mac UI here. But this is Java. This is the original Java code compiled to WASM running in the browser. So that this may happen. So my message is that Java is actually surprisingly non-bad in the small. You have mostly batteries included with a really good standard library. The language has changed to make things a lot easier than them used to be in the days of Java 8. The editor and IDE support, it's just so unbelievably much better than you would get with, and not wanting to mention any names, Python. And so that really is I think, the key driver for this. The weak point is third-party library integration, but JBang will solve this problem for you. JBang is a great tool. So I think these notebooks could have legs, and so I will continue to watch that notebook space. And who knows, maybe we will see Java again in the browser. So, any remaining questions? Go put them into the chat. Let me go through here and see what people have been asking. So yeah, people seem to be doing this. People do the scripting. Someone says they use Quarkus, and well, I would not use Quarkus for these kind of small things. To me, that's overkill, but hey, whatever works for you. So for me, the beauty of this approach is you don't really need anything. And that, I think, makes it so much easier to reason about. You have some simple project, you know it's not gonna last very long, and you don't want to have to make an investment in something complicated that distracts you from the task at hand. And so with plain old Java and a few simple tool choices and setup choices, that has become, I think, eminently practical. Like I said, it used to be, I have to do a lot of these small tasks. It used to be I would routinely go to shell. I never go to shell anymore. When I have an old shell script, I look at it, I don't understand it, I rewrite it in Java. All right. Oh, and someone said the Java playground. So let me show you the Java playground. So Oracle came up with this thing where you can do Java right in the browser. Unfortunately, it is not super useful. I mean, the one useful thing it has is that you can pick a Java dialect. I think at least you can. But you can't really do anything with it. You can't share these snippets, they don't give you any way of doing that. And obviously you can't debug them, they don't affect your local file system. So this is more of a way of running JShell without some of the creature comforts that JShell has. So again, this playground could be fantastic. I've been talking to people at Oracle and say, why did you make it so that it is more notebook-like, so that one can save files, and maybe that'll come. They're definitely seeing the light. It's just hard for this team to put together something that's brand new. But that's kind of the thing you want. You want to have something that's online, that's shared, where you can put in code snippets, where you can save them, share them, and so on. And then the usual creature comfort that, I want autocomplete. I want to have easy error message displays, which this thing doesn't have. If you make an error, then you just get an ugly old style error message. But yeah, it is what it is. Okay, so I hope this gave you some kind of food for thought on how one can use Java in perhaps a new and surprising way that is not just there for your big iron project.
Hey Kai, by the way, I'm Keto. I was supposed to be the moderator, but I had technical problems, so Ken kicked off the session. But I don't think you have to wrap up quite yet. You can last as long as you want. But I did want to say, first of all, that the Java playground, if it was anything like a TypeScript playground, I think that'd be great, because there you can at least share snippets and stuff.
Yeah. It can be done, right?
Yeah.
And we can dream there could be a debugger. Yeah,
that'd be nice.
Definitely. Right? And so some such thing, if you look at Google Colab, right, you can share, which I do all the time there. And Google Colab's killer feature is actually the AI. Right? It is surprisingly good. Like when I do something with Matplotlib, that it'll suggest something. It'll of course not be the plot that you actually want, but it'll be a plot, and I'm not an expert in it, so I take it and then I can mess with it.
Okay, cool.
Go ahead.
One question for you. So often when I write a shell script, the reason I do is because no one has to install anything, right? So it just runs out.
Yes.
So and I may have missed that at the beginning. What is your suggestion, like, for if you want to write a script that is going to be usable on like another system?
That's a good question. So nowadays I always install Java with SDK man.
Okay.
And I don't think SDK man is like a big lift.
Right.
And so that's what I would suggest that they then do. Now that has not actually been the primary use case for me. It really has been to automate like drudgery,
Right.
of which there seems to be a lot in my life. I do a lot of stuff with new publishing systems, and they never really think about how to automate anything. They just assume that the author is going to be mindlessly putting together complex hierarchies of this and that.
Yeah, I can see that.
But yeah, so I do think the SDK man is the answer. You can actually use JBang to install some Java as well. I don't have that much experience with it. So if all you want to do is get Java running on some other system and you use JBang anyway, then JBang is good enough to install a Java version.
Okay, cool.
So, yeah, so maybe that's the first thing to look at. It's just the reason I use SDK man is, of course, because you can switch it.
Right. On your local system, it makes a lot of sense to be able to swap stuff.
Yeah. But otherwise, JBang. So the short answer to how to do anything is first try to do it with JBang.
Makes sense.
Yeah. But some people say they didn't get permission to install JBang on some system, so that's why I went to some level of detail to see how you can do it with plain Java.
Okay, cool. All right, do we have any more questions for Kai?
I'm looking through here. Do I know of any books that do this? I don't think there's enough material for a book. It's so I actually have as many of you know, I have this 2-volume tome, this core Java, 2,000 pages or so, and then I have a 500-page condensed version of it. I just asked ChatGPT to condense it. No, I didn't. But that only talks about the more important APIs, and that's probably more in the spirit of this. But that might still be too long. Yeah, maybe there should be a book for Java for the scripter. Because the missing piece that I glossed over today is, what parts of the API do you use? And so there's a certain parts of the file I/O and of streams that I use all the time, or of course collections, or just daytime handling, that kind of things. And other parts, I could kill it. Okay, well, I think that we should keep it within the hour so people can go and see whatever the next talk is. Anyone who has questions knows how to contact me. I'm sure just ask ChatGPT, and I'll be glad to take this discussion further.
All right. Well, thank you very much, Kai, for the awesome presentation. I write a lot of shell scripts, and I play with the JBang, so that was great for me too. So,
did you actually manage to hear some of it, or were you?
Yeah, I did. I heard most of it. I showed up like 10 minutes late. So.
Okay. All right. Well, I'll see you around then.
All right, guys, enjoy the rest of the conference. There are lots of great talks, so please stick around or at least catch us on YouTube. Thank you.